Mendeleev, once again, in 69, started by organizing the periodic table by simply atomic mass. It was actually quite simple, as he just took the lightest element and then lined them up in order to heaviest. But then what he did, and this will help you on your puzzle today. Okay, that the first thing on your puzzle you'll want to do is to put them in one big line, like he did. Then what he did is he took sections and started moving them underneath each other and found patterns in the columns as well. So that going across, they got heavier, but then when he looked down, they had similarities in the columns. Okay? Mendeleev's table had some errors though. By using the masses, sometimes the properties weren't lining up like they should, and then we'll learn how that got fixed here in a second. And this is actually what his original periodic table looked like. He just started organizing them. Like our video talked about, is he was able to predict properties of things that hadn't been discovered yet. So he put blanks in his periodic table, or gaps, because he's like, okay, this doesn't really fit this family. Something else must belong here. And then he could predict things about it, and then down the road, we discovered it, and it matched, which was pretty cool. So he was able to predict the properties of 3 of the missing elements in his table. Obviously, our table has grown a lot since then in the amount of elements we have, but it was a good start to the structure of it. All right, so then everyone, focus back up here. In 1913, so about 50 years after Mendeleev first built this table, a guy named Henry Moseley kind of adapted it more to what we know today. The reason being, at this time, is this is when we discovered the proton. And so now we could organize the periodic table by atomic number. Which, if you look at the periodic table in front of you, that's the way it seems to be organized. Is if you read left to right, it counts up 1, 2, 3, 4, 5, so on and so forth. But then if you notice down at the bottom with the masses, that it's still pretty close according to Mendeleev. But using the protons fixed some of those discrepancies that we had, where we ordered them by mass, but it didn't really match up according to property. Right? Like, so look at on your periodic table, if you look at cobalt, number 27, and then if you look at nickel, you actually can see that nickel's a little bit lighter, so it goes down when normally it should have gone up. Right, so Mendeleev would have had those backwards accordingly. Okay, so from having this atomic number, we now have what is known as our periodic law. Let's just talk about this in general to help us better understand it. So like your classes that you go to every other day, okay, are called your class periods. What is that? Why do we call them a class period? Mitchell?
Because they have just like the certain spot, like a certain amount of time.
Yeah, so a lot of times the period is like a certain amount of time and then it repeats.
So it's like the beginning and
end. Exactly, just like a period of a sentence is the end and then it starts again, right? This is why that is called the periodic table, is because as you read across, you get to the end of a sentence and then it repeats itself, okay? And it's pretty cool in how it works. So we see this pattern in these graphs right here. So look at this with me.
How's that graph different?
There's a few different ones we'll look at here actually. So, but they all have that same idea. So notice that this is the atomic number. So notice that we see it's climbing, it's climbing, it's climbing, and then it goes down. Climb, 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 down. Each of these segments represent a new row. That as I go across the row, it increases. But then as I go back to the beginning, we have to climb again. Yours, I think, is a reverse graph, right? Where is it this one? Is that the one I gave you on your notes?
No.
That one?
No.
That one?
No.
Oh, it's none of them? That one?
That one.
Oh, okay, there it is. So this one, you can see, same theme, that the dots climb. We do have some exceptions, right? They don't follow the pattern perfectly, but then when I get here, that would be the end of a row, and then it starts again. End of a row, starts again. And we see that for a lot of different things in which the elements do. Okay, so a lot of these we've done before, but if you've forgotten or you need a reminder, you might want to write them down in your notes. So these are just some different ways in which it's organized so far that we've talked about. So we've talked about the blocks of the periodic table. So we have the S, the P, the D, and the F. Right, so in case, hopefully we're really good with those now because of configurations. But if you're not, you might want to write them down. Okay? Another way, though, that we'll talk about them that maybe we haven't referred to as often is in terms of the main groups. So the S and the P block together are known as the main group elements. So if I say main group elements, I mean the S and the P. So if you want to make a note of that, that might be a good idea. This middle section, does anyone know what we call this in terms of a group?
Secondary group.
That's a good guess.
What?
So that's like the primary. This one we call, those are the transition metals. So the main group ones are the purple ones. So the S and the P together. And then the F block we call them the inner transition metals. The inner transition metals. Why would I call them the inner ones when they're down here? Yeah, because remember they actually fit up here in the end. Okay? All right, another pattern, we've talked about this before, but we'll get more into it, is that when I use the word group, I mean a column. You also could use the term family. Family or group are what we use for column. Okay? And then what's the word I use for a row? Because we don't really call them rows, we call them, I heard somebody whisper it, we call them periods. Right? That the rows on the periodic table are known as a period. Okay? So kind of some vocabulary to be aware of. We also talked about this back in the first unit, that we have different metallic properties in how the periodic table is organized. So this one corresponds to the one at the very bottom corner of your notes, okay, where all the yellow ones up here are metals. So if you want to label all of those light colored ones as our metals, and then you might want to shade out the metalloids a little bit darker, because I think they kind of look about the same color on yours as the non-metals. So you might want to shade these blocks a little bit darker to point out that that is the metalloid group, to separate that from the non-metals. So another pattern we see is that as I read left to right, things become less metallic and more non-metallic. All right, and then if you flip to the back side of your notes, I've given you a periodic table that has all the families, so you don't have to write all them in. But these are the different families of the periodic table we have. The main ones that you should focus on are alkaline metals, alkaline earth metals, and then the halogens and the noble gases. Those are really common ones we talk about a lot. And then, of course, we have the transition ones in the middle. Lanthanides and actinides are easy to remember if you just look at the periodic table, because the first one of the family is lanthanum. The first one of this family is actinum. Right, so they're just named after those. Okay, and then the thing with the groups, like I mentioned, is there's similarities. That's why we call them a group or family. Is that as I look down this column, and I'll show you 5 of these next time, you'll be able to see that there's similarities within the family, but then there's also differences. And some families are a lot more similar than others, just like I'm sure with your families. Right? I'm sure some of you have a family where you just are all the same, just smaller versions of each other. And you might have another family where you and your brother look alike, but you don't really look like your other siblings. Or maybe you're the odd one out of everyone else. Right? So we see that same thing with the elements as well. So next time, like I said, I'm going to show you these physically, what they look like. But then what I'll also do is I'll drop them in water, and you'll see that their behavior is similar, and it comes down to this configuration thing. that all of this family has that S1, S1, S1 pattern. 2S1, 3S1, and because of it, they do similar things. They're not exact. You'll see that we have to watch videos of the last ones because I can't get those legally. They won't sell them to anybody, but we'll see that it's also somewhat similar.
They don't sell them to anybody?
Well, at least not to high school teachers. Sure, if I had a high enough level of clearance, maybe, but. And then finally, before we do our little activity, this is kind of the goal here, okay? Is that this whole idea of something being periodic is that it happens every so often, right? Like we see this decreasing pattern and then it repeats. Decreasing pattern and then it repeats. And that's the way the periodic table is set up as well. Is that as you read across a row, we see patterns and then the pattern stops. And then we come to the next row and it happens again. Once again, there's some weird ones, right, that kind of mess up the pattern every once in a while. As we're talking in this chapter, don't focus on the weird ones. Because if you get too caught up on the exceptions, you don't see the overall picture. Focus on the overall picture because by just seeing the overall, I can tell you one element and you should be able to tell me a lot about it because of these patterns in the end.